We're going to continue looking at some graphs of exponential functions. These are going to be a little bit more difficult. They're going to have a lot more stuff involved in them. All right, so let's take a look at this example. So our a here, the number in front, is actually a -1. We see that negative sign there. That's actually a -1. The b here, which is the base of the exponent, is 2. The h here is actually, well, it's the opposite of this number, so it's -3. And then our k here is 6. Now, this is not going to be exponential growth or exponential decay because of this. Okay? The a value must be positive for it to be growth or decay, so this is not either. Our horizontal asymptote is equal to the k value, so it's y is equal to 6. So at 6, right here, we're going to have a dotted line that this graph does not cross. Now, one thing to point out, the a value is negative, and that usually flips it over, so it's going to be upside down. We're going to start in the middle of the table. Now, the middle of our table is actually going to be the h value. Okay, in the previous examples, the h value was 0, and this one it's -3, so -3 is our h value. But we can also find that just by setting the exponent equal to 0. X plus 3 equals 0. Subtract 3. X equals -3. So the middle of our table is -3. We have 2 to the left of that, so -4 and -5. And then we have 2 to the right of that, so -2 and -1. And now we're going to plug each of these into the equation -2 to the x plus 3 plus 6. All right, so we're going to plug each of these values into this equation. So that we can fill out our table. So let's start with the first one in our table, -5. That's the first one, right? Yeah, -5. So if y is equal to, now it might help to put the -1 times here. That might help us do it. So I'm going to do that. -1 times 2 to the -5 plus 3 plus 6. So that's -1 times 2 to the -2 plus 6. Okay, we can use a calculator to do this. All right, we need to do the exponent according to PEMDAS. So -1, 2 to the -2nd power is 0.25. -1 times 0.25 is -0.25. And -0.25 plus 6 is 5.75. So that is what we get when we plug in -5. We get 5.75. All right, next we plug in -4. So y is equal to -1 times 2 to the -4 plus 3 plus 6. So it's -1 times 2 to the -1 power plus 6. You can put this 2 to the -1 in the calculator. That will be 0.5. And -1 times 0.5 is -0.5, which gives us 5.5. So plugging in -4 gives us 5.5. So let's put that in our table. Next, we're going to plug in -3. Y is equal to -1 times -3 plus 3 plus 6. That's -1 times 2 to the 0 power We do the exponent first. This is negative 1 times 2 to the 0 power is 1. Anything to the 0 power is 1. Negative 1 times 1 is negative 1. And negative 1 plus 6 is 5. So our next point in the table, 5. All right, let's plug in negative 2. Y equals negative 1 times 2 to the negative 2 plus 3 plus 6. Negative 1 times 2 to the 1 plus 6. That's just negative 1 times 2 plus 6. This is negative 2 plus 6, which is 4. So our next one, 4. Okay, next we are plugging in negative 1, the next one in our table. So y equals negative 1 times 2 to the negative 1 plus 3 plus 6. Negative 1 times 2 to the second power plus 6. This is negative 1 times 4 plus 6. Negative 4 plus 6, which is 2. So our next negative 1, 2. All right, now we have everything we need to graph this. We have all our points, so we can put this on the graph. All right, so negative 5, 5.75 is like right here. Negative 4, 5.5 is right here. Negative 3, 5 is right here. Negative 2, 4 is right here. And negative 1, 2 is right here. Okay, so we can actually see this is upside down. And it's because of that a being negative that it's upside down. So it gets very close to the dotted line on this side. And then over here, it goes like this. All right, so it does look like exponential, it's just upside down. The domain is still negative infinity to infinity. It's still all real numbers. That's not going to change. But the range is going to change because it's no longer going up from 6. It's actually going down from 6. So we would say that the lowest it starts is at negative infinity. And then it goes up to the dotted line, which is 6. And we use a parentheses to show that 6 is actually not part of it. Okay, it never actually hits 6, it just gets close to 6. Okay, so we've got some more graphs that we're going to be doing for practice, numbers 4 through 6 on page 92.